Okay, we are connected up to channel 2 and we are feeding in a 600 hertz signal uh, that is 20 millivolts peak. We're getting it from this AC calibration unit, this 5200A Fluke. Beautiful AC calibrator, capable of producing voltages from a millivolt up to well, with an external unit I could go up to 1000 volts. This particular unit will go up to 100 AC volts, and we can go from 100 hertz up to a megahertz. Right now we are feeding in a 600 hertz signal, and that signal on the 5 millivolt per division scale, we're up 4 divisions, so that's 20 millivolts peak AC. And this is the 5200A is an RMS unit. So in order for me to provide 20 millivolts peak, I had to provide 14.14214 volts RMS. So I've already calculated what the RMS values necessary to give me the peak readings are, and I'll cite them as we go along. Alright, so like since we're on the lowest range setting, let us take a look at half scale, which would be 7.0710 millivolts. Seven point zero seven 1068. Alright. And there we are. And we see that we are exactly half scale. So that worked out alright. Alright, let's go ahead and progress to the 10 millivolt per division range, and we see right now that we are running positive negative 1 millivolts, so positive and negative 1 division, which would be 10 millivolts up and down. So let's go ahead and put ourselves at full scale. And full scale would be 40 millivolts, and I want to be at 28.28427, so .284 27. Alright, here we go. There we are, full scale. Good. Let's go ahead and progress to the next range setting, which would be 20 millivolts per division. We see now that we are at half scale, which is to be expected, because we just went from 10 to 20 millivolts per division. So we doubled it, doubled our requirements, and therefore pulled ourselves down half scale. And at 20 millivolts per division, 4 divisions, that would be 80 millivolts required. That would mean I have to have an RMS input of 56.56854. So 56854, 56885. Alright, we're going to come online. There's full scale. That's exactly what we predicted. And we're going to go ahead and go to the next scale. This would be 0.1 volts per division, or 100 millivolts per division. We're right now at 50, so we're going to drop down to half scale. Oops. I'm sorry, we were at 20 millivolts per division. We're going to go to 50 millivolts per division. There we go. And at 50 millivolts per division, we're full scale on 20 millivolts. Because that was 80 millivolts. And if we go to 50 millivolts per division, I require now 100 millivolts of input. So 100 millivolts would be 70.710. So we have to change our value again. Bear with me. 70.171. .068. Alright, we're coming online. And there we are at half scale. Okay, if we wanted to go to full scale, that means we need 200 millivolts coming in peak, and that would mean that we would have to have 141.4214 RMS volts. So let's go to standby. Okay, we're on 50 millivolts per division. There's 4 divisions up. That's 200 millivolts. 200 millivolts requires 141.4214 millivolts RMS, and that's what we're providing, and we're getting the right response. So let's go ahead and raise ourselves up. We are now at 0.1 volt per division. And that brought us to half scale, which is what we'd expect. And if we want to go to full scale, we need 400 millivolts coming in. That would be 282.84. 282.84. There's full scale. 8427. And then if we raise ourselves by a factor of 2, we're going to drop the response to half. So there we are, up and down 2 divisions. At 0.2 volts per division to be 0.8. .2.4, excuse me, that'd be 0.4 volts, 400 millivolts. Okay, 282.8427, that's true. Alright, if we want to go full scale, I need 800 millivolts. And to get that, we would go to 565.685. 565.685. And we're at full scale. Okay, we're going to raise our range. We're going to 0.5 volts per division. Well, 2 divisions would be 100 millivolts we're putting in right now. Sorry, it'd be 1,000 millivolts. We're putting 800 in right now. So if we wanted to get 1,000 millivolts, we have to go to that'd be 70. 0.707, so $707,107. And there we are at half scale. And if we go to 1 volt per division, and we're only up one division. If I want to go full scale, then I need to now be at 2.828. So alright, we're going live. There we are at full scale. We're at 1 volt per division. That's plus or minus 4 volts. And we have 2.828427 volts RMS coming in. So everything is looking great. Let's go ahead and drop ourselves to half scale by raising our range up to 2 volts per division. Okay, we're on the 2 volt per division scale. That means we have 8 volts going up or down, and that would require 5.656854 volts RMS out of the fluke. So I've got that dialed in, and we're reading full scale right now, not a problem. If I take us to 5 volts per division, we're going to be in an odd position because we're 8 volts up and not 10. So we want to be 10 volts now. That requires a reading of 7, 0, 7, 1, 0, 6, 8. 7, 0, 7, 1, 0, 7. There we go. Exactly half scale. And if we are now to go full scale, then I need 14.14214. .142. Okay, going live. There's our full scale. That would give us 20 volts up and down. And that's the end of our range at this point. If we were to use the probe and divide by 10, we could get a few more steps. But we're done with channel 2. We're going to move to channel 1. So give me a moment. Okay, we're on channel 1, and we can see our probe's been moved to 1. We have 1 depressed here. And we see that we are on 5 volts per division, so that means we have 20 volts up, and we are feeding 14.1421 volts RMS from the fluke and getting it. So that's good. Let's go ahead and reduce that voltage. Take ourselves to 210. That would mean we need 7. Seven point zero seven one zero. 7.710. Okay, there we are at the half. That's 10 volts up, 10 volts down, so that worked out right. And then we're going to go to, going to 2 volts per division, and in which case we would like a reading of 5.65685. There we are, full scale. Okay, we're on 2 volts per division. We're up 4 divisions, that's 8 volts. We have 5.65684 volt RMS coming in from the fluke and getting our 8 volts peak, and that's exactly what we wanted. So if we go to half scale, then I want 2.828427, 2.828443. There we are at the half scale reading, and that's exactly where we wanted to be. We are 4 volts up. Alright, so now if I go to 1 volt per division, we should be full scale. And we are. Okay. So now I want to go to half scale, then I would like 1.414214. 1.4141. There's our half scale. That's 2 volts up, 2 volts down. If I go to 0.5 volts per division, we should be now max, or no, up to our max point. Up 4 divisions, down 4 divisions. Okay, so I now want to go to so 0.51, 1.52. So we want to go to 1 volt. And 1 volt would be 0.707. So here's 707, 107. There's our half. Good. Alright. At this point I want to take myself to 800 millivolts, which would be 565. 0.6854. Okay, and change our scale to 0.2 volts per division. We should be, there we are, full scale. And I want to go to half scale now, and half scale would be 0.1 volts times 4 would be 400 millivolts. That'd be 282.8427. .8427. Okay, and we are at half scale. Beautiful. So now let's reduce our range again. We're going to 0.1 volt per division. We should now be at max. There we are. And we want to reduce ourselves to half scale. So right now we're at 0.4. We want to go to 0.2 volts peak. That'd be 200 millivolts peak. Means I need 141.4214. So 141.121. Half scale. Beautiful. Change our range to 50 millivolt per division. We should be max. There we go. And you want to be half scale now, so it means we need 100 millivolts coming in. That would be 70.71068. 70. Seven, 1, 0. There we are. There's our half scale at 50 millivolts per division. That puts us at 100 millivolts coming in. If we go to 20 millivolts per division, we'll be over range, so we need to reduce ourselves to 80 millivolts, which would be 56.56854. So 56, 5, 6854, 6, 8, 5, 4. Alright, and we have to reduce our range now to 20. There we are at maximum. Okay. So we want to go to half scale now. That would be 28.28427 millivolts RMS. 28.28 427. Alright, there's our half scale. If I go to 10 millivolts per division, we should be full. We are. And if I go to half scale on this, then I need to be at 20 millivolts. That'd be 14.14214. So 14.1214. We're at half scale. If I go to the final range for full scale, and we're done with 1. So we are linear in DC, we are linear in AC, certainly at 600 Hertz we're linear. We've just tested both ranges. We're beautiful. What we're going to do now is we're going to test the frequency response of this unit, which it's supposed to be a 100 megahertz unit. So we should be flat from DC up to somewhere up in the we're 3 dB short at 100 megahertz, so you know, somewhere up around 50 megahertz we should start sloping off, losing, and we'll be, if we set ourselves for a signal like we have here, where we're at 4 divisions up, then there is a marking on the gradical that shows us the 3 dB point. So if we're above that gradical reading, then we're good. So we're going to go ahead and check that, and I'll show you what I mean. Bear with me.